Okay. Okay, so the question is that we're going off is if someone you loved was killed in front of you, but someone created a copy of them that was perfect right down to the atomic level, would they be the same person and would you love them as much? I would say no, they wouldn't be the same person.
Everything is the same down to the atomic level, but
Mentally, psychologically, they aren't the same person.
psychologically they aren't the same person because someone can have a very similar brain,
but be a completely different person.
As soon as the copy is created, they might be the same person for a little, but they would change fast.
Yeah.
Especially if they knew they were a copy.
If they knew they were a copy and then they questioned themselves, it'd be like, who am I? What am I? Am I just a copy of someone who's actually dead? Oh no. And then they'd end up dying again because
Psychologically,
they can't.
they could not handle.
Nobody can handle being told you're a copy of someone who is dead. Unless you're insane like us.
We probably couldn't even handle it.
I'd be like, oh. Well then. I could handle it because of nowadays what they have. Like what they've simulated and stuff. But in the past, nobody can handle it.
Nobody can handle it. We couldn't even handle it. We don't even know how to imagine it.
Our minds cannot actually process that. Just like the fourth dimension.
There's so many things that our minds cannot handle.
Yeah. Speaking of the fourth dimension, the fourth dimension is basically time in a nutshell. Ish.
Kind of. The thing about dimensions that I've thought about and kind of realized, so there's 3 dimensions that describe space, right?
Yes, but we only see
Length,
2.
Width, and depth.
We only see 2. Actually, we only see 2, but we live in the 4th.
We see 2, we interact in 3, and we perceive 4. But the thing is, the 4th dimension of time doesn't deal with space.
Time is its own thing.
Time is its own thing. There could be multiple dimensions within time.
Yeah. The 4th dimension is basically time in a nutshell, but it's also not time. The reason it's not time, though, is because it's just rate of change. Everything is rate of change, and we know that from calculus. We know that there's a 4th dimension and kind of studying from a little bit of calculus.
Through math, we can represent the other dimensions.
But we can't actually see them.
We can't actually interact with them.
Just like wormholes are good on paper.
Wormholes
are so interesting.
I mean,
the best way to hold them open is with exotic matter.
Exotic matter.
Yes, but the thing is, if you hold them open with exotic matter, would you be able to go through?
We don't know. We
because
don't even know how to create them.
But the reason I say would you be able to go through is because gravity wants to close it, and exotic matter keeps it open. But exotic matter works in all ways. So you would need a thing of you would need more exotic matter that is stronger than the gravity trying to close the wormhole.
You need to equal it out.
Yes, and then you would be able to fully travel through. But if you equal it out, one will slowly decay and take over. To where if the exotic matter didn't decay as fast as the wormhole's gravity did, then what would happen? It would expand and keep on expanding, probably, until it just swallows the entire universe.
Possibly. Because it might expand to the point, because gravity is coming in, exotic matter is negative matter.
Yes, it would be pushing out so much. We don't know
how it would work. Because I'm pretty sure the exotic matter would likely decompose faster.
Yeah, so
it would decompose, it'd be open for a certain span of time, and then pop close.
which that is why there's string theory, where there's a cosmic string going through wormholes, right? That ties the entire universe together, which, who knows, those strings could be made out of exotic matter as far as we know.
Yeah.
Which, that would be crazy, but we can't detect exotic matter, or can we?
I'm not entirely sure.
Because exotic matter has negative mass. So it's almost impossible to detect.
What does negative mass even look like? Right?
Yeah.
What would it feel like? What would it look like?
What if black holes are just a ball of exotic matter? No.
Black holes are
White
fascinating,
holes.
though. We have not recorded a white hole
Because it's not possible in our dimension.
in our dimension.
In other dimensions, it's possible. That's why black holes could be a portal into another dimension that you cannot come back from.
The thing is, black holes could be spitting out matter in another dimension, but
But black holes decay.
you can't go through a black hole.
Not
It
alive.
You wouldn't make it through.
No,
alive.
because time is so weird with black holes. But the thing is, you know how black holes decay? The things that
Yes.
decay off of them go faster than the speed of light.
Hawking radiation.
The radiation goes
True.
faster than the speed of light.
Because it has to escape the gravity.
Yes. And if light can't escape the gravity because it's going too slow, then that means gravity is actually faster than light. So the force is faster than light itself and pulls the photons or warps it. And then the Hawking radiation is even faster than that force
Because
because it's able to escape.
it's coming out from inside the black hole. And if that Hawking radiation, if that radiation is able to record data, then we could potentially find out what is inside a black hole
Yes.
by taking that Hawking radiation and translating it back into the data.
Which we could make another Earth-like planet from that data we collect from the Hawking radiation. Rest in peace, Stephen Hawking. From that Hawking radiation, we can make another planet to sustain ourselves when planet Earth is slowly ceasing to exist. Which it is.
It's going to die.
It's ceasing to exist at a more accelerating rate. But the fastest
is it,
way it's
though?
going to die...
It is accelerating. What were you going to say?
Fastest way it's going to die is from humans. Not from the sun expanding, from humans.
As of right now, if we continue along how we are going right now, humans will destroy the Earth.
Yes.
But we don't know what technology could come in the next few years. Even like the next 10 years, some insane technology could come
Yeah.
that could pull us back from
That.
destroying ourselves.
Which people are trying to, making electric cars, but that's not working fast enough. Because everybody's addicted to fossil fuels.
The world is addicted to fossil fuels. The thing we need to address.
So we're using dinosaurs as fuel. Thank you, dinosaurs that lived longer than all humans.
Yeah. If the, I don't remember what grade it was, but the quote stuck with me for a while. If the entire span of Earth's life
Was compressed into a day.
90-minute soccer game, the dinosaurs would have just left, like, less than a second ago.
Wow. But if the entire Earth was compressed into just a day, we are alive for 0.00000000001, right? Or is it 0.3?
It's 3 seconds.
Oh yeah, it is 3 seconds.
There's a really cool
video
about it by
Prince EA.
Prince EA.
But my favorite one was what was it? Korgog in a nutshell.
I don't remember. I don't know how to say it.
I don't know how to pronounce it.
In a nutshell.
But it just like it starts and right as you click start, it starts counting the seconds. Just.
Oh right,
And then it explains human history. Then it goes to Earth history. And then when it gets to the universe history, you can't even see where humans have started.
You can't even see where the Earth started, can you?
Yeah, you can.
Okay, you can see.
You can't even see where humans have started. You can see where Earth started, just not where dinosaurs either.
You can't even see where dinosaurs started.
And then you zoom into dinosaurs, and you could barely even see human history.
Yeah.
I'll be right back.
Okay. Be quick. So.
Sorry, we got some weird idiots or
They're not.
people who like to be disruptive
we've
with
got
the
some-
entire school,
We've got some loud people in the other room.
and they just came in anyways. So it's not like we're trying to record anything. It's not like we want it dead quiet.
We don't necessarily want it dead.
Well, we want the background noise to be non-existent.
Anyways, what were we talking about?
Dinosaurs and time.
Time.
So with the human, how
You
they
can barely see the human time, and then
Yes.
it goes down. And he talks about how. Your eye just twitched.
Yeah, I know, from anger.
Okay, calm down.
That's how I calm down, is twitching my eye, just like
Twitch.
okay, my eye's used to twitching because it just twitches itself sometimes.
Time, seconds.
Time, how
Um,
if the whole Earth lifespan was compressed in a day, which that is 4.5 million years or longer.
I have no idea.
Probably
we
longer.
Could probably look it up, but
Because I can't remember his name. But where he tried to find out something to do with lead.
oh right, because you can judge the
Earth's age from
carbon dating.
Carbon dating, yes.
Carbon dating.
He tried to do that in the Arctic, but that was in the Arctic where
That
it
brings
was
us-
completely frozen for who knows how long, right?
Right.
But guess what?
What?
That's when it got cold. Not before, when everything got washed away from like the first ice
no.
age.
The carbon dating with lead from the Arctic. If you could do that, it froze over there. So you might be able to date it farther back to before we had those ice caps.
That's just it. We don't know. And the Earth was under a bombardment for like, I don't know.
For when our solar system was just barely starting, there's so much things going around. We were getting bombarded by meteors.
For a couple hundred years.
Yeah.
Couple thousand maybe.
That's one of the theories of how we got our moon, was a big meteor knocked a chunk of the Earth out.
Which that's why, or that could just be a big meteor that hit Earth, that tilted its axis, that created water on Earth, and that created Earth today as we know it.
Yeah.
Because it could have been spinning so slow, and that could have hit it, and spun up its orbit.
There's just so many things that could potentially happen.
That's another theory, by the way, with making Venus normal, is you strike it with something to make its orbit faster.
That would take a lot.
Yeah, I know, but that's probably what happened to make our atmosphere the way it is now, and to have that tilt.
Yeah.
And that's why we have seasons.
Yeah.
So,
I like having seasons.
I do, but don't. Because I like it the first few weeks of winter. Same with the summer. Because it's like, okay, first few weeks, yay. And then it gets later, it's like, Jesus, cold. And then summer's like, yay, it's warm. Jesus, hot.
And there's, yeah.
I like summer better, though, just because you could do more stuff.
Yeah. Back to space.
And that's how we don't know our age, the age of the Earth, because we didn't know when the bombardment ended, when water showed up, when it froze.
We can kind of figure out the age of the Earth, but it's a lot harder to figure out the age of life on Earth.
Yes, actually, it's not
true because
that much harder. And we know
microscopic life.
Yeah, but the thing is, we don't know how old the Earth is, so we can't really say. If it was full in one full day, it can't be 3 seconds because we don't know. We don't for sure know.
Okay, but about 3 seconds because the bigger the Earth, the longer the life of Earth is, the shorter we are here for. But,
yeah.
Yeah. Where was I going with this?
I have no idea.
Anyways,
I'm tired, man.
we're becoming an opera. Life on other planets.
Is very, very, very possible.
It's more than just possible. Statistically speaking, you're like 99% that there's gonna be life.
Well, so mathematics were like, there's 1 in a billion chances that life on another planet exists. And then, okay.
That seems like some crazy odds.
But when you fully think about it, it's still 99%.
Because you look at the night sky, you can see a tiny speck of all the stars that are in our...
Not even a tiny speck. Way smaller.
Way smaller than like a tiny speck.
Because...
Of what is even in our galaxy.
Yes, but...
And then that galaxy is just the tiniest
because there's
speck.
Billions and billions of galaxies. And in each side galaxy...
Inside each galaxy, there's...
Yes.
Millions upon millions of stars.
Billions, even trillions of stars.
Countless stars.
So there is no way
and then each
that
of those
we are
stars,
not alone.
Each of those stars has countless, could have like a few planets orbiting them. How could there not be life other than us?
Plus, there is a planet that is like in the game Subnautica.
Where it's water.
It's just water that is around, all of it is like 2 kilometers deep. Who knows what is swimming under there? It's not all of it is 2 kilometers deep, but
the shallowest part.
Or, the shallowest part. Which, that could be a possible place for humans to go
and then
live.
And that's when underwater cities could become...
Which, the only problem with that is water pressure. That's like the...
Domes.
Yeah, but still, those can get destroyed. Because you know the thing of, I think it's Courage or something. I don't know how to pronounce it in a nutshell. The deep sea nuke. How it would just go...
Bloop, bloop. What would happen if you detonated the biggest nuke we've got in the deepest part of the ocean?
The biggest nuke ever created in the deepest part of the ocean, in the Mariana Trench?
Yeah.
People would think tsunamis or earthquakes everywhere, when in all reality, bloop. And then the bird would be like, Get stinky. Sure, we'd have radiated fish and a little bit of radiated water.
But not enough to do any damage.
Yeah. We would be perfectly fine. The fish around it would not.
Yeah.
But the reason I say we would be perfectly fine is because the water pressure down there is so intense. Right as it explodes, it expand outwards and instantly collapse.
Yeah.
Because it is so intense.
But that's at the deepest part of
Yes.
our ocean.
But the deepest part is like 10 kilometers, right? On that planet, though, 2 kilometers is the shallowest?
I don't know how deep the Mariana Trench is.
I don't either for an exact
I'm pretty
measurement.
sure it's deeper than 10 kilometers.
It could be, could not
Because I'm positive it's deeper than 10 kilometers. Because how high is Mount Everest?
be. True.
And we can go deeper than that.
But anyways, the shallowest part is 2 kilometers, and the
There's still
deepest
gonna
part
be-
here is like deeper than 10.
It's way deeper than 10. But
It might
there's
be,
still a
might
lot
not
of-
be.
it's deeper. There's still a lot of pressure at 2 kilometers.
Yeah.
But we could handle the pressure with suits, diving suits. We could handle the pressure just fine. divers-
Submarines.
Divers can go down.
So
deeper than
technically, the game Subnautica would become a real life thing
could become reality.
if we went to that planet.
That planet, yeah.
Actually, there is a planet that it rains rocks.
What planet is that?
I don't know the name, but the planet is so weird. Do you want to know why? It's so close to its star, and it orbits only around its star. So one side is always facing its star, and it's so hot that it melts rocks into lava and evaporates. And then it goes over to the other side, which is so cold that it instantly freezes them and makes them rain.
So is that planet, because of that, just slowly moving farther and farther away?
I'm not sure, but
By like tiny bits at a time? Because
it
it's
rains
melting
rocks.
on one side, putting it on the other side, and it's just slowly the entire planet is shifting.
That would be so funny. Like a billion years later, we're all living there. This used to be the planet that used to rain rocks. It was like, wait, what?
It used to rain rocks here?
Yeah, it used to be about 9 million miles that way. It's kind of like Mercury. I bet there is a spot on Mercury that you could live in if you had oxygen. Because it would be the perfect temperature. But it's such a small spot that we couldn't do anything about it. It'd probably be the width of a normal house.
Population 1 on this entire planet.
No, population 2.
This was a bad idea.
They forgot their spacesuits.
There could also be life on rogue planets.
Oh, yeah.
Planets without a star that are just flying through the universe. Which would be interesting
You know
if you could.
You know how they were like, oh, there's planet 10. Planet X.
Yeah. Kind of.
I don't think that's a real thing.
Why?
Because we would have known about it by now. Sure, math is like, hey, there's 10 planets in our solar system. But math could be incorrect because you could have a wrong variable.
I'm pretty sure there is another planet in our. There could be.
There could be, but I don't think what
Because-
everybody was saying with Planet X, how it's like 10 times bigger than Earth, and it looks like green and all this other stuff. I don't think it looks like that.
Maybe not, but
Plus, it's like.
if it was 10 times bigger than Earth, then
Plus, did you see the video Mark Roberg did about it?
how far away it is. The thing is, if it's that much bigger than Earth, its core is a lot bigger and could be a lot hotter than Earth's.
Yes.
Which then heats the outside.
But the reason I say I really don't think that it is because it could be a rogue planet that has been caught by sun's gravity.
And then starts orbiting it and is now a 10th planet.
Yeah.
But anyways,
Which it could not get caught and could just be like, hello, and just leave. And no, it'd be, hello.
Slingshot. Bye.
Yeah. And who knows? That planet could have life on it, like you were saying with the,
Yeah.
if it had water.
But what would be interesting is if there's a rogue planet that's coming close to Earth, or like close to our solar system that we can reach, that it could sustain life. We go on there as it's passing by, get a colony, get people who are willing to leave Earth forever. Get a bunch of people that are willing to do that and go and live on that planet and set up stuff, mine stuff. While it's close enough to Earth, we can still get supply missions, set up everything,
The only problem
and then
with
live
that.
there. And then you're traveling through.
The only problem with that, though, is Voyager isn't even out near. For how far it isn't even near. It's like probably halfway.
Yeah, it's to the closest, not even halfway to the closest star. Or to that planet, sorry.
Yeah.
Right, that's what you're meaning?
Yeah. So if we sent a rocket there, I don't think it would make it within the people's lifetime.
Yeah, but...
Because astronauts, the bone decay and muscle decay, they have to fight that so often.
Which is why you'd want to do artificial gravity by spinning.
Yes, but the thing is, we don't have that yet.
Yet.
Which, I don't know why we don't have it yet.
The technology is there. It's just very expensive.
Which you could put it in two. You could launch one part up, and then launch another part up, and then put them together.
It would have to be built in space. You couldn't launch it in just two separate pieces.
Unless you have it be a small part of the rocket that just rotates freely. Which that actually would probably be better for launch missions, like to go farther.
The thing is, you still have to build it in space because that it would have to be massive.
Not necessarily.
Spinning to give you the true feeling of Earth's gravity, where you don't feel the spin.
Well, if you have it about the size of normal classroom, from one end to the other, you have about, say, 7 feet up for you, then the giant mechanism that is spinning it, and 7 feet on the other side.
Then your feet would be feeling more gravity than your head. You have to have it far enough away where that effect is so minimal.
Yeah. But
for it to work properly.
If you did it to a certain speed, to where you could even just lay down to just feel the normal, like gravity, then guess what?
Your bone mass still starts to decay.
But not as fast. Plus, you could sleep there.
You'd just be laying down.
You could be sleeping there, though. And the thing is, if you did that on small, like, ships, like rockets, you launch it up, it wouldn't be as fast as muscle and bone decay. Wouldn't be as fast as just sleeping in normal, like the space station.
Or you take and build a rocket in space that is pretty big and rotates. And you have...
Which it'd be better to be do a space station by then.
You have rockets that can go from the planet to that, and that other rocket is just orbiting the planet.
Yeah. What? It's not that it's boring or anything. My eyes just like close.
It kind of
Close.
seemed like you were just like, boring.
No, my eyes are just like wanting to close itself and then just. And I'm trying to pay attention to stay awake, but it's like, no.
Anyways, pretty much a space station, but with fuel and everything like that to get out of the Earth's gravity, transport you to wherever you're going, and then take a lander, go down onto the planet, and then go back to the station, and then go home.
You know what? I think this is the end of this conversation.
Probably.
Because we have stuff we need to do today.
Right. Yeah, this is the end of this.
All right. Well, wait. Well, we'll see you guys in the next podcast, which comment down below what you think we should talk about next. Make sure it's a deep question. Because if it isn't a deep question,
We probably won't do it.
or we might do a bunch of questions like, what is your favorite color? And then you could answer it like that and just like, blue. And then it's like, oh, okay.
We're done now.
Yeah, like that fast.
And please make them appropriate.
You make them inappropriate, we'll delete them. So, see you guys in the next episode.
See you guys later.